Okay, cool. I guess we can get started. I think everyone can hear me in the stream right now. So yeah. Uh, and hello, my name is Siraj. Today we're going to be learning about Git. You've probably heard of it before, or you maybe have even used it. Or maybe it's completely new to you. Whatever your experience, I hope there's something you can take away from this talk. Because in my opinion, it's one of the most crucial things you can learn as a software developer. During the presentation, feel free to ask questions, especially during the demo. I am keeping an eye on chat, so if I miss your question, I will come back to them at the end, or just keep spamming them and I might see them. And there's one question right now. Are we going to be using the GitHub CLI? No, we're not going to be using the GitHub CLI. We're going to be doing everything on the command line. Just because I think that's the best way to learn. Cool. So our agenda for today, I'm going to start off with Git and GitHub basics. I'll explain how it works, as well as a demo going over it. Then we're going to dive into more advanced topics such as branches and merging, GitHub issues, CI/CD, open source projects, and yeah. I'm going to show you use the GitHub on the browser, but I'm not going to use like the desktop application. Cool. So just to begin, I want to talk about what exactly is Git. And all it is it's a version control system. And that's pretty much my presentation, so you guys can go home now. But no, I'll take some time to explain what it is. And typically in software development projects, including in your school assignments, things are done in small chunks, or you might do an all-nighter and finish it all in one go. But either way, when you get into complex or larger projects, you're going to be doing it in small little chunks. You might do like one function and then another function, or like one part of the application and then another part, and then slowly build towards that larger application. When we get to these larger projects, we want to be able to track all of these little changes over time, go back in time, see who's responsible for what. And Git gives us this ability to track every addition, deletion, and change to our project, and record it if we ever need it in the future. And that can be really powerful. I know when I was in an undergrad, there were like a couple assignments where I just did something completely wrong. I wish I could go back in time to a previous version where my code worked and where I was still on track. So Git will sort of give you that ability. Next, it's also a command line tool. Although there are UIs and GUIs available, it was primarily built for the command line. And for this presentation, we're primarily going to be using the command line for it. It's also an open source project built, started by Linus Torvalds. Linus Torvalds is the person who developed Linux, and it was to make open source projects, it was to make open source collaboration for open source projects easier. But I'll get into that a little bit later in this presentation. So next up, I want to talk about what is GitHub. And believe it or not, Git and GitHub are two separate things. GitHub is a Git repository hosting service. It's a place to store your repos that you create with Git. And so there are a couple of alternatives to GitHub, most commonly GitLab and Bitbucket. You can use any of these, and for more or less, they do the same tasks, but sometimes they'll add their own features and stuff like that. And these features can make Git a much more powerful tool, but we'll get into that a little bit later on. So what can it do and why is it important? I mean, it's cool. We can make repositories. Why do we care about this? The first reason you're probably going to use it is a way to store your data and files, or your coding projects with version control. And I've graduated my university 6 months now, and during my undergrad, I worked as a teaching assistant for 5 different courses, and I've seen a lot of different ways students tend to store their code. I've seen students just save it on their computer. Some use a USB stick or hard drive to back it up. Some put it on Dropbox. And I've even seen students email their code back and forth as they made changes, which was an interesting strategy. But I mean, hey, if it works, right? But if I'm going to be honest with you, all of these have their flaws. Your computer could get corrupted, crash, get stolen, or you might have to spontaneously reinstall Linux. Like, I've seen all of that happen, and students lose their code, and like the night before an assignment have to email being like, I lost my code, my computer crashed. They could lose their USB stick. Dropbox isn't a terrible solution, but it's kind of a pain to deal with, especially when you're dealing with software projects. And I'm not going to go over why emailing your code back and forth is bad. I think that should be self-explanatory. And if you've done it before, it's okay. Please don't do it after learning about Git. So either way, there's a lot of different methods you might be using to store your code, which may or may not be great, and it can come back to bite you. So Git is one solution to storing your code. It also gives you the ability to track your changes, additions, and deletions for your code base. And I've mentioned this before, but just being able to figure out, oh, I made these changes between my last couple commits, or this is what my code looked like a month ago, and this is what it looks like now. That can be really, really powerful, especially in more complex code bases. If you fax your code, write your code by hand, great. There's definitely better ways than like faxing your code. It also gives you the ability to roll back to previous versions of your code. Let's say you want to go back to your code from a month ago. You can do that really, really easily with Git. And one of the most important features is it helps facilitate collaboration with others. You can't send your USB stick back and forth between developers. I guess you could fax your code between developers, but like, I don't have a fax machine. I don't know lots of developers who do, and like, it could be a pain. Like, imagine just faxing all of your node modules to someone else. Like, it would suck. But yeah, it's great for sharing your code with others and collaborating with them. It's also really important for open source projects, which I will talk about later. But if you want to contribute to open source projects, definitely gonna have to learn Git. So why is this important? Well, there's a lot of advantages to it. And if you plan on becoming a professional software developer, I guarantee you'll encounter a team that's using Git to manage their code base. So you will have to learn it. It doesn't matter if you're a web developer, a mobile developer, a data scientist, a blockchain developer even, you will use Git because your teams will use Git and because it's so useful. So next I'm going to do a little demo of it. But before I dive into the demo, I want to talk about some commands I'm going to be using and just clarify what they're doing. So the first one is Git Init. And this command initializes a new repository in your local folder. And this is how you're going to start every new Git repository. It's super simple. Just write Git Init. The second command is Git Add. And this command adds files to be staged for committing. And this might get a little confusing here. Don't worry about it. It'll make a bit more sense in my demo, which I will show in a second. So just bear with me. Git Commit. Git Commit takes all those files that have been staged for a commit, groups them together, and assigns them a commit. It records these changes to the repository. Git Push pushes your local commit to your remote repository. So it takes your code from your computer and sends it to GitHub or GitLab. So pretty important. Git Pull. Git Pull gets the latest changes from origin, which is GitHub or GitLab, and pulls them to you and merges them with your existing code. Git status shows the status of the working tree. I'll talk about the working tree in a second. And finally, Git branch will help let you list, create, and delete branches, which I will talk about later as well. So one more thing before I dive into the demo, I want to explain what the working tree is. So there's a couple different stages in your working tree that you should be aware of. One is untracked. That means Git is unaware of your file. The file is untracked and the repo has no idea what the file is, no version history, has never been staged or committed to the repo. Next is tracked. That means the repository is aware of the file, but it's not staged or in the working directory, but it has been committed or added sometime in the past. Staged means the file is ready to be committed and placed in the staging area awaiting the next commit. And finally, modified means when a tracked file has been changed, but the changes are not yet staged. So I have a question that's a really, really good one. Tell us the difference between Git fetch and Git pull. So typically we use Git pull, but the difference is Git fetch will get the latest changes from origin and not merge it. So Git pull will merge your changes, Git fetch will not merge your changes. Cool. Are there any questions before I dive into the demo? I don't think there are. Okay, cool. We can just jump into the demo then. So let's say I'm a student again. Okay, if you guys aren't too familiar with the terminal just lets you access shell commands and call commands directly from the command line. And this is, I'm guessing you've probably used this a little bit in school. This is just bash, and yeah. I guess if you have questions, just ask me, or if you're not sure what a specific command is, just let me know and I'll go through and explain it. So let's say I'm a student again and I have a hello world assignment. So I'm going to create a hello world file in Python, and I'm going to go into it. I'm going to add just print hello world. That's pretty much it. Can we get a Vim tutorial next? Actually, there is someone I know who would do a great Vim tutorial. So if you want it next, let LCS know and they can definitely arrange it. But now I have my hello world.py file. If I want to run it, I just call Python, and there I have my hello world. Is it cut off? Okay, we will fix that in 1 second. Okay, that should be fixed now. Hey, if you want to give a Vim tutorial, I think Nosher would be super open for that. So yeah. Okay, so I have my completed assignment, but I want to put this on, I want to create a Git repo. So the first step I'm going to do is type in Git Init. Actually, real quick, I just want to show you that I have nothing in this folder except for my hello world.py. That's all that's in here. Now, if I initialize a Git repository using Git Init, it's basically going to tell me that I've initialized an empty repository in this folder. And now, if I do ls, you'll see that I just have my hello world.py. And the reason is because the .git folder is hidden. So if I do ls.a, you'll see that we have a .git folder, and that is where your repository is hosted. That's what your repository is, and it's going to track all of the changes we made. Now, in my opinion, the most important command is git status. Git status lets us know the status of our working tree. So if we type in git status, we can see that I don't have any commits yet. I'm on my master branch and I have one untracked file. Remember when I was talking about the stages of a working tree? So this is the first one. The file is untracked. That means our Git repo has no idea about it. It's never been committed. It has no version history. And it's like, okay, cool, you have this file. I don't know what to do with it. I want to add it to staging to be committed. And it's pretty simple. I just type git add and then the name of my file. So if I do that, 1 second, my computer is laggy. I blame Nosher. Okay, so I did git add and I added my file. Now if I do git status again, come on. Okay. There we go. It's telling me I still don't have any commits, which makes sense. I haven't committed anything, but I have one change that is staged to be commit. So this file is now being tracked and it is staged. If I want to commit this, all I do is I type git commit -m. -m just means my message, and I'll say like initial commit. So now if I enter that, it'll tell me that I have one file change, which was my hello world, one insertion, which was my print hello world, and it created this commit. So now if I do git status, it's going to show me that there's nothing to commit because I already committed my file. Not sure it's just the cause of all. I know, right? Like, not sure what you doing. So what if I have this right here, but I want this to appear on GitHub. I just don't want it locally. I want this actually online and backed up on GitHub. So it's pretty simple. All I do is I go to GitHub, and you'll need to create your account. You're going to go to your repositories and you're going to create a new repository. And I'm going to call this Git Demo just because, and I'm going to make it a private repository. Now, this is really important, especially for school assignments. Public repositories mean anyone on the internet can find your repository, take the code, and see it. Private repositories mean only you and who you enable can see the repository. If you're developing a school assignment on Git, always use a private repository because you don't want like people just taking your school assignment and like submitting it themselves, because that's academic misconduct. So if it's a school assignment, always use a private repository. So I'm going to give it a name. I'm going to say it's private. I'm just going to go ahead and create the repository. Now, it's really nice because it tells you exactly what to do, but the only ones I'm really interested in are these 3 commands. This one basically tells my repository that this is the origin, that when I push my code, I want you to send it to this URL. So I'm going to start by just adding that to command. I'm also going to switch over to a main branch instead of master because I prefer calling it main just for consistency. And now if I want to push, I just copy this 3rd command. And what it's going to do is it's going to push to GitHub. And now if I refresh this repository, amazing. You can see it right here. You can see my hello world.py. All my code is here, and it looks amazing. Cool. Now, let's say I keep working on it, or if I do Git status, it says it's clean. We don't have anything to change. Let's say I want to keep working on it. And this time I want to add exclamation marks. So now if I do Git status, it's going to say that this is not staged to be commit. Now this file is still being tracked, but it's just not staged to be committed. It's that fourth phase we talked about where it's modified but not staged. So now if I want to add it to staging, all I do is say git add my hello world.py file. If I do git status again, it tells me it's been staged. And now I can commit it, add exclamation marks, and I give a nice little commit message that lets me know what I did this change. And now if I do git push again, we can see that my code has been updated. And if I go back into my repo and I go into my commit history, we can see that initial commit, and I can go back into the code and we can see what we wrote here, as well as go into our latest commit and see how it was originally this line that we changed into this line with exclamation marks. Pretty neat, right? So that's the very basics of Git. A couple more things I'm going to show you. Yeah, let's say I'm working with someone else and they add a file on GitHub without me knowing. So let's just add a README real quick. We'll commit that directly to the branch. And now our GitHub repo, our origin, has a README and a hello world. But locally, I just have my hello world. Now, if I want to get that README from my origin back to my local files, I simply do Git Pull. And this will take in the changes from my origin on GitHub, pull it, and merge it with my local changes. So now if I do ls, you'll see I have the README as well as the hello world.py. So let's go over another scenario real quick. Let's say something really, really bad happens and I spill apple juice or a beer all over my computer and all of my files are gone. And I'm also going to remove my Git file just to show you that there really is nothing here. It's all gone. I can't submit my assignment. I have to call my prof just crying and screaming, being like, oh my God, all my files and stuff are gone. I need an extension to submit or something. How do I deal with this? And just real quick, another question is, which editor would you recommend for Git? You actually don't use an editor with Git. You use your terminal, which is your command line. And typically I use bash, but you can also use like vshell, fish, like tons of other stuff. You can customize this shell, or this terminal however you want. So it isn't an editor, it's your terminal that you're interacting with, if that makes sense. Cool. So I've lost all my files. How do I get it back? Well, luckily, if I refresh my Git repo, all my files are still here. I haven't lost all of my work. What I can simply do is I can go here to the little code tab. I can copy its URL, and I can use a little command called Git Clone, paste in the URL, and clone it to my local directory. So now if I just cd into my Git demo, I can see I have all my files as well as my Git repository. And if I run hello world, it works perfectly. Yeah, VS Code has great extensions for Git and stuff that makes it a lot easier to use. But if you're starting out, I highly recommend just learning it on the command line because I think that's the best way to learn. And then you can move on to like using extensions and stuff. But yeah, VS Code is great for that sort of stuff. uh, what else do I want to talk about? Okay. Also show one more thing. Let's say I create a new file just called test.py. We're not going to put anything in it, but I just want to show you what the working tree would look like. If I go back into my hello world, let's change this to a capital. And if I do git status again, you can see that this is telling me that this file has been modified, but this new file I've just created is untracked. Test.py is untracked because I haven't added it, doesn't know about it, but hello world is tracked because I've added it to my repo before, so it can recognize that, hey, this file has been changed. It's being tracked. It's just not staged for a commit. So now if I want to add both of these, I can do git add hello world as well as test.py, do git status. You can see that both of these are now being staged to be committed. I can simply commit them, they add test.py. And if I go back here, we can see that my test.py with no code has been pushed. How to stage a PR. Yes, I'll go over that. I'll show you how to stage PR or go through a PR with you after I go through the rest of my presentation. Just because it's not super beginner friendly, so, but I'll talk about it for sure. Yeah, okay, I think we're good on that part. So I think that was a pretty good demo of Git. Does anyone have any questions about what I've covered so far? And this is when the basic stuff is going to end. So we're going to dive into a couple more advanced topics. Oh, sure. LS, all that means is I want to see all the files in my folder. So let's say you go into your Finder or Windows Explorer and you see all those files listed. LS is just the command line way of seeing all of those files without like opening up your Finder. It's so I know like, oh, I can see my hello world and my test and my readme. ls-a will show you hidden files. Not all files are visible. So your Git repository is an invisible file that can only be seen if you do like ls-a. So that's the difference between them. Typically, you only really need to do ls. There's very few reasons you'll actually need to use ls.a. Second is pwd. PWD stands for Print Working Directory, and it's useful for helping you figure out where you are in your sort of computer. So right now I can tell I'm in my folder, like my user, a code folder, the Git demo. It tells me exactly where I am in my directory. Yes. LS is short for list, so you get a list of files. PWD means print or present working directory. Yep, exactly. And in Windows and PowerShell, it'll be different, but this is specific to Bash, which is most likely what you'll be using. Okay, cool. I think that covers all of the questions so far. How do you change your working directory? What if you're working on different projects? Yeah, that's actually a really good question. And I'll dive into Bash a little bit. So let's say I'm on this little folder right here, my Git demo folder, but I want to go back to my code folder. What I can simply do is type cd, and what that stands for is change directory. And I can do ... which will bring me up to the folder up top. So now I'm in my Git demo folder. You can see that I have a second Git demo folder that was back here. If I want to go back into that, I simply type cd git demo, and it will bring me back there. I want to go to code. Give it a second. cd / that, and now I'm in my code directory, and I can see all of these files I've been working on. You can also do cd path. PWD stands for print working directory, and it'll tell you your current directory that you're in. So if I go to my Finder, if I go to under Siraj and then code, I should be able to see all of these files. Yep, no worries. So I'm just gonna hop back into my Git demo. And I'm back where all my, yes. So ... / is just to go up one directory. So right now I'm in my Git demo directory, which is under another Git demo directory. So if I do cd ... I'll go up one folder, and now you can see that I've gone from this directory to this directory. Yes, and then you can also chain them. So let's say if I wanted to go up two directories, I can do cd ... / and another cd ... / and that'll bring me up two directories. So now I'm in my like personal folder. Okay, so do you use Git to create your code, or would you create these files using a different IDE and then use Git commit to commit and push this code? You don't use Git to create your code. You use Git to sort of manage the version history of your code. So you would create your files elsewhere. What I typically do is, one sec, I'll just dive back into my Git demo folder. If I want to create a new file, I'll say touch, which is basically create a new file. Say text.txt, which will create a text.txt file, which you can see right here. And then I would edit it. I would use Git to add it to my repository. Yes, so anything that begins with a Git is a Git command. So Git Init, Git add, Git commit, Git push, but other things like ls or cd or pwd or clear are all bash commands. Yeah. So if it has Git in front, yeah, exactly. Git is just a history tracker. It tracks what has been changed in the files you've committed. Are there any more questions before we move on, or? Okay, I'm going to take that as a no, but if you have any other questions, feel free to ask them. I'm more than happy to answer. But we'll dive into a couple more advanced things, like starting with branches and merging. So, like I mentioned before, one of the big reasons we use Git is for collaboration. And this is because it allows developers to diverge code from the main development branch, work on it without affecting the main branch. And then later on, they would merge it. But let's say we have a web application in our master or main branch that's working perfectly. It's great. But the team asked me to put in a timer or something, or another feature. What I'll do is I'll create a new branch. I'll work on it, I'll develop it, and once it's completed and ready, I'll take those changes and I'll merge them back into my master branch or my main branch. So then my main branch will have all those changes I just made. Now, this can get kind of complicated, especially when you work on with a large team. Let's say we create a new branch from master to complete my work. The main branch can still be modified by other developers on the team when they merge in their changes. So let's say I'm doing work, another developer also does work before or creates a new branch before I've merged my changes. Then I merge my changes. So my master has the original code as well as my changes. That other person on my team is going to have to take the changes, the modified master branch, and sort of merge both of our code bases together. And it can kind of lead to more complex merges that are dealt with through GitHub. But if you're just new to Git and it's your first time learning it, I wouldn't worry about it too much, especially if you're just using it for yourself. Are there any questions about branching and stuff? And I can do a demo of it later if we still have time at the end of the presentation. But does anyone have questions about branching right now? Okay, let's hop over to GitHub Issues. And this isn't something I've included in previous presentations about Git I've done, but it's something I've learned recently and I've used a fair bit. But GitHub basically has an inbuilt system to track issues related to a repository. It allows you to break larger issues into smaller tasks, facilitate conversations about those issues, talk about what might be causing it, potential solutions, stuff like that. It can be used to plan projects, create roadmaps. And one thing I found very useful is it's great for finding answers to problems relating to a specific repo. And it's a nice alternative to Stack Overflow, believe it or not. That can often be more useful, especially if you're dealing with like specific code bases. And this is what I found happening, just because I would like I would use this NPM package and I would like run into an issue and like I'd Google it, but I wouldn't get the answer I want. But when I went into the issues tab of the repository, I could search for it and find much better answers to my problems that just like didn't show up on Google. So real quick, I'm just going to show you like Node.js. This is a bit overkill, but it just shows you how many issues you can have. They have 12,000 closed issues and like 1,300 open issues. But let's say you're getting a segmentation fault or something, you can Google segmentation faults and search for it, and you can find all of these issues that are specific to Node.js that might help you sort of figure out what might be going wrong. So if we go into this one, it talks about what's causing it, and it talks about potential solutions and stuff. So don't worry about it too much, but it's something I found myself using more as a professional developer. So yeah, next let's talk about CI/CD a little bit. And CI stands for continuous integration. And all that means is it's a fancy word for the code base being built, compiled, tested, linted, and or more when new code changes are pushed/merged. So when I did git push, my code just like went right into the repo. But we can set it up so it runs tests, it runs a linter, it builds, and sort of double checks to make sure all of my code is still good. Because It's really easy for a developer just to say, oh, I forgot to run my test before pushing, and then suddenly you have broken code that no one knew about. So it's a good way to prevent human error, and it's really, really simple to sort of implement. So if you're a bit more experienced with GitHub and like Git, I strongly recommend learning CI/CD just because it's so useful. CD refers to the code being deployed every time changes are pushed slash merge. And the reason we do this is to improve our ability to frequently deliver apps. And how software development has shifted over time is it used to be like we would do a massive release every 1 to 2 years, and that had issues because you would have bugs and then you need to put out fixes and patches and stuff like that. I think Java used to put out a new version of Java every like 2 years, but now they do it every like 6 months just because it's way better to do that. It supports a more agile workflow. And the software industry is trending towards shorter releases. And I know for some web applications, they'll have multiple releases in a day. So they'll like work on code and then release it the same day. And they're able to do that because of a very strong CI/CD system that double checks their code and makes sure it's working. So there's a couple tools doing this, including GitHub Actions, GitLab CI/CD, Jenkins, Travis CI, Circle CI. I personally like GitHub Actions the most just because it integrates with GitHub really, really well and just makes it really easy. And I'll kind of show you one project I was working on. So this was a website that I was developing in React, and we developed a CI and deployment pipeline. So if I go into the details of this, what it does is it installs all my dependencies, it runs my linter, it runs my build, just make sure that it can actually build and it works. And it does that for every single push I make to my repo. We also developed a CD pipeline, so a deployment pipeline. Not this one, this one. But what this will do is every time we merge our changes into our main branch, it'll automatically deploy it to wherever it needs to be. So it's just less work for me to have to manually deploy it every time. And I'll quickly go through the file because it's pretty simple. You can see it's like 20 lines, and it's really, really simple to develop. So if you're a bit more experienced with Git, I strongly recommend learning it because it's super simple. Next up, so yeah, that was CI/CD. Next up is open source projects. I'll just briefly go over this. And open source projects are just projects where anyone is free to use, study, modify, or distribute your project. And Git is used to help facilitate open source projects, allowing anyone to contribute. It's a great way to learn new skills, contribute to something, solve a problem, honestly improving your resume. Employers love it when you've contributed to their open source projects, especially if it's like their company's open source project. And yeah, a lot of these projects can be found on GitHub. Some of them are in GitLab, but definitely you need to learn Git in order to be able to contribute to them. So they're definitely really cool. I definitely recommend looking into them once you get comfortable enough, because like it's a great way to learn. So just key takeaways from this presentation and kind of things I want you to, learn. First of all, Git is a crucial tool in software development. It's incredibly useful. It's used everywhere, and it'll save you from yourself because you're your own worst enemy. You make mistakes all the time. It's easy. I do it all the time, even like as a more experienced software developer. It happens to the best of us. It will really, really save your bum from yourself. It's also simple enough to start using today on your school projects, but has enough features to support much larger and more complex projects. Um, like I talked about CI/CD merging and stuff. You don't really need to do that. You can just commit and push your code, and that's more than enough. Like, I strongly recommend putting all of your school projects going forward on a Git repository, because you'll prevent, if your computer breaks down or something, you won't lose your code. B, you'll have all your projects stored for in the future. And C, it's in a private repo, so no one can really take it or anything, which is really, really nice. So I strongly recommend from this point forward, do not email your code to yourself ever. Just, if anything, like USB sticks are fine, although like it hurts my soul a little bit. Just don't email your code to yourself, no matter what you do. Use Git. Please use Git. Yes, if it's a public repo, so if it's an open source project, it's great because people can see your growth and they can see the growth of your project and you can track it over time. But don't put your school projects on a public repo, only put it on a private repo. Otherwise, it is academic misconduct. So please use private repos for school assignments. And that was a really good point about seeing projects evolve over time. And I'll kind of dive into one of my projects. You can go to Insights. It'll kind of show you who's been contributing to your projects. You can see how many contributions there's been, who's been writing what. Some people have like 50,000 lines added. Happens. Usually those are just like package lock.json files and stuff. You can see traffic. You can see tons and tons of stuff. Show you one more thing. This is kind of cool. So this is our Git branches. Like I said, it can get super complex later on when you start branching and merging and stuff. But you can see this is our main branch, and we have a whole bunch of branches as like different people developed different features on it, and it's a little complex, looks a little daunting. Don't worry about it too much, but yeah, it can really give you a lot of insights into the progress of your repository. Yes. Yeah, if you want to show employers your school assignments first, just make sure your professor is aware that you're sharing it, because I know some professors are like that. You can make some of them public. I have a Android app I developed in my final year that we just put on GitHub, and it's shown to all my employers. But just make sure you get permission for that before. People couldn't really copy this assignment, so it was fine, and I put it online after the course is completed. You can also share private repos with whoever you want, so you can definitely make that available to employers and stuff. And finally, final takeaway is that Git is something every software developer should learn. Please don't be intimidated by it. It's really, you can start small and build up. Just start using Git. It's the best way to do it. An older project on Android Studio. How can I transfer that onto GitHub? Super easy. You just go to your root directory in that project. You'll do Git Init. You'll add all your files, and then you'll push it to your repo. You'll commit it and then push it into your repo. Similar to how I did in my demo, how I initialized the repository, I added the files for staging, I committed them, I added the remote URL, and then pushed it. And that will send that to GitHub, if that makes sense. I'll also just quickly talk about some resources. There is a Git website. I also linked the Git cheat sheet. And you should also look into the GitHub Student Developer Pack. It's really, really cool. It'll give you access to GitHub Pro as well as tons of other features. And it's definitely really useful if you're a student. I am a little sad that I don't get access to it anymore, but if you haven't already, I highly recommend using it. So I think I'll just spend the rest of the time just answering questions or going over things you guys, anything Git related you guys want me to talk about. Thank you very much for attending, and thank you for LCS for letting me give this talk. And yeah. Oh, how did I become so handsome and talented? Well, I learned from the best, and that was you, Nathan. Where do I work? I work for a startup in Toronto called Cinesend, and we develop a secure online streaming platform for like film festivals and movies and stuff. So I mostly work with like React, but I also work on Android and Fire TV apps. So yeah. And also really cool, I probably should have mentioned this earlier, but when you go to apply to software dev jobs, tons of them will ask for your Git repo because they want to see what projects you've actually contributed to. So during your time in school, definitely develop your GitHub profile because that's your portfolio, and it demonstrates to employers that you can actually build something and you're capable of like actually coding. So as a first, actually there is, 1 second. Got a great link for you that I just need to find. So, yeah. One thing I can recommend is going to this link, and it just has a link to a whole bunch of projects that you can develop in whatever languages, and it'll walk you through exactly how to do them. So if you're like not sure what you want to do, or you're unsure about a specific language or something, just take a look at some of those tutorials. They walk you. Oh, did it get blocked on Twitch? Okay. I will send it to Nosher. Man, they just blocked my link. Okay. I sent it to Nosher, who is going to send it in a second. Yeah, that is a great resource. I actually use quite a bit myself. But I would recommend starting with small projects. Sometimes students, especially like people who are newer to it, dive into a massive project and it just becomes this like dragon they can't really handle. Start small and work your way up. That way you can build your portfolio. You'll have a ton of tiny projects and can demonstrate you can do a lot of different things. Start small and work your way up is the best way to do it. Yeah, tic-tac-toe calculator is great. Yeah. Can probably stop sharing now unless anyone else has something they want to ask about. Yeah, actually, it's kind of a funny story. Like, it was actually my New Year's resolution. I wanted to code like every single day, and like that was a terrible idea. Like I just got burnt out at some point, but you can definitely see I coded a lot. A lot of them weren't readme commit. Like once you start like working at a place and like doing open source projects, there's so many like little things that will just add up and stuff. But yeah, just code a lot and you'll build up your commit calendar and like no problem. work definitely help like fill it up because I'll be like doing like 2 or 3 pull requests a day or like committing a lot, stuff like that. So I haven't. I might in the future. I just think that sometimes it's easy to get burnt out if you code every single day, and it's nice to have breaks every once in a while. Like, I think I coded for like a month straight at one point, and then I was just like, no, this. I just like took a couple days off. I'm like, I can't do this. Oh, all the time. Literally, I had to. 90% of my job is figuring out how to do my job, right? So once you graduate school, you're given all of the, like you have like a fundamental set of skills, but there's tons and tons you won't know. I look at bugs all the time. I find out new things related to React all the time. Recently, I was given a Kotlin project in Android that I had to develop. And I've done like Java apps, but like I'm mostly a web developer. So I was like, okay, I'm gonna have to learn this and develop it. And that's a part of being a developer. There's always gonna be something you don't know. It's really how well you develop your ability to learn. Kotlin is amazing, so much better than Java, especially for Android development. No Kotlin slander in here. But yeah, if there is something you're not sure about doing at work, and especially if you're a junior developer or a co-op, you can always ask your senior developers or your team lead. That's what they're there for, and they've been doing this stuff for years, so they can always point you in the right direction and help you out. So don't be afraid of not knowing how to do something. How to face imposter syndrome. It happens to everyone. You're here where you are because you've earned it, and it definitely can set in really hard some days. Yeah, I'm not sure if I have the best advice for that. Just know that it's something everything goes through with it, but you've made it where you are, where you have for a reason. When did you figure out what you wanted to specialize in? Um, Literally like the November before I was going to graduate, because I was like, oh shoot, I have to graduate in like May. I need to find a job. What am I gonna do? So I spent some time like learning. I really wanted to be a web developer, so I spent some time learning React and a couple of other things, and eventually landed me a React development job. That being said, I'm always learning new skills, and like that's what life and job is about, just constantly learning and growing new things. I'll always have like my background in web development, but I can always dive into something else. I also tried out a whole bunch of things and just decided they weren't for me. Like I did data science for a while, and I thought I wanted to do it, but I turns out I just really didn't want to do it after a while. But I really enjoyed web development. I really like building things, and that's what web development is for me. I just build applications, and it's nice. Yeah. Yes. Can I send links in the chat? Not sure. Okay. You can add me on LinkedIn and message me, or you can add me on Discord and message me. I get a lot of spam on my Discord though, so maybe message me first before you add me as a friend. But I will send Nosher my LinkedIn if you guys want to see sort of my career path a little bit. I haven't updated it in a while, and you can also send my Discord profile if you rather message me on Discord. So yeah. Yeah, definitely a lot of great questions in the chat. So Um, I'll sing Wonderwall once they get 100 followers. I thought that was the rule. Okay, well, it's been great chatting with you guys. Feel free to reach out to me, ask questions, whatever. Happy to answer them. So yeah, take care.
So I just want to say to everyone, thank you so much for coming, and thank you so much to our amazing speaker. I feel like I learned so much. I'm really hoping the audience learned just as much. And yeah, I hope, can you guys look at the QR code on the screen? Suraj, could you put that up? Yes. Or feedback about what you guys thought about the event. So you can tell us like whatever you like, things that we can improve, or just something overall that you liked really, that was good about the event. Yeah. So we'll leave that up for like a few minutes and then we're gonna end the session.